Ever pondered why a heavier object requires more force to move, or why a car accelerates faster the harder you step on the gas pedal? The answers to these questions lie in Newton's second law of motion, a fundamental principle in the world of physics. Newton's second law of motion states that the force acting on an object equals the product of its mass and acceleration. In mathematical terms, this law takes the form of a simple equation. Force equals mass times acceleration, or F equals ma here. F represents the force acting on the object, m signifies the mass of the object, and a stands for the acceleration of the object. Consider a toy car on a smooth surface. Push it gently and it'll slide forward leisurely. But give it a hard shove and it'll zoom away at a much faster pace. The difference in acceleration between the gentle push and the hard shove is governed by the force applied, illustrating Newton's second law in action. Just when you think you've mastered the art of understanding forces and motion, Newton throws in a third law. Newton's third law of motion states that for every action, there is an equal and opposite reaction. In other words, any force exerted on a body will create a force of equal magnitude, but in the opposite direction on the object that exerted the first force. Imagine a trampoline. As you jump on it, you exert a force downwards on the trampoline. The trampoline in turn exerts an equal force upwards, propelling you into the air. This is Newton's third law in action, often described as the action-reaction law. It is this principle that explains how forces are created and transmitted between objects. In a nutshell, Newton's second and third laws of motion provide a comprehensive explanation of how forces and motion interact in the physical world. The second law highlights the relationship between force, mass, and acceleration, while the third law emphasizes the mutual forces between interacting objects. These laws form the bedrock of our understanding of physics and have countless applications, from engineering to sports and even space exploration. So, the next time you see a car accelerating down the highway, or watch a rocket launching into space, remember the principles of force and motion explained by Sir Isaac Newton centuries ago. These laws remain as relevant today as they were in the 17th century, helping us make sense of the world around us.